When I started learning Angular, I wasn't aware of the different change detection that Angular has. I started my Angular apps and discovered I have performance problem and was trying to improve the performance problem, and then discovered the OnPush change detection strategy. I wasn't even aware that Angular has a third change detection strategy. You can go completely zoneless. You can make your Angular app work without zone.js. And in this mode, Angular works without zone.js in a manual change detection. And you can actually make your entire Angular app zoneless, or you can make a subtree of your components work zoneless. And this is the most performant change detection strategy that there is. It's better performance than the OnPush and the default change detection. So if you're aiming for good performance in your Angular app, stay tuned and listen to this lesson. So up until now in the change detection chapter, we learned about two change detection strategies that Angular has. We talked about the default change detection strategy, which we referred to as an automatic change detection strategy. And we also talked about the OnPush, which we refer to as a semi-automatic change detection strategy. And just to recap what we already learned, we talked about the default change detection strategy. In the default strategy, if this diagram represents your component tree, so in the default change detection, if something happened in one of your components in your component tree, let's say the bottom one, the one that is marked in red, then the entire subtree will undergo change detection. This means that the dynamic values that you bind in the template will be recalculated and the view will be updated if needed. So the entire tree will trigger change detection from the top component down the tree to every one of the components, and will recalculate the dynamic value and update the view if needed, and then it will finish the change detection cycle. So in the default change detection, a lot of components will get rendered when they don't really need to be rendered. So it's really expensive in terms of performance to use the default change detection strategy. And we highly recommend, especially if your users are going to your app from a mobile device, we highly recommend to not use the default change detection strategy. And another change detection strategy which we learned about is the OnPush change detection strategy. And the OnPush change detection strategy, basically, when you look at a component in Angular, when a component in Angular is created, it is represented by an instance of a class called component ref. A component ref holds a class called viewRef, which represents the view of the class. The view of the class, and it holds, for example, the template and the binded values that we bind to the template. And the viewRef holds a dirty flag. And basically, in the default change detection, whenever you subscribe to something async, it's working with zone.js. So whenever you're doing something async in your app and you subscribe to something async, like an event, a timer, a promise, an observable, so the viewRef in the default one is automatically marking the component as dirty. This is why the entire tree of components goes to a change detection cycle if something happened, because it's automatically marks the view as dirty. But in the OnPush, the viewRef does not automatically mark a component as dirty when something async happens. It actually marks as dirty when certain conditions happen. And when those certain conditions happen, only then the view is marked as dirty, and only then when the view is marked as dirty, it means that Angular will go to trigger change detection on the component in the current change detection cycle, or in the next one if it's not in a change detection cycle. So in the OnPush, the view is not marked as dirty automatically. Now, looking at our code, if you want to shift to OnPush change detection strategy, you go to your component and you mark change detection strategy OnPush. So, and this we already learned, so this is a quick recap. And also, we learned about the conditions that the OnPush triggers change detection. So we have a few conditions that the viewRef will mark the component as dirty in an OnPush change detection strategy, and only when they happen. And the first one is event. So if you subscribe to an event in a component that is in change detection OnPush, if you subscribe to an event, for example, what we did here with the click, handle click, so when an event happened, after the event, change detection of the component will be triggered. But not only a change detection to the component itself, but also to up the tree of the component. So if we have an event, so it actually marks change detection. If we have an event, for example, on this component, it will mark change detection. It will trigger change detection on the top one and on this one, and perhaps on this one, depending if this is marked in an OnPush. So it will traverse down if that component is not in the OnPush. But usually when you work with OnPush, you're going to work, you will probably want to work where your entire tree is in OnPush. And in this case, only the top one and the actual component which had an event will trigger change detection. So the next cause of a change detection in an OnPush is when an input is changing. So in this mode, if you have a component with a change detection on push and that component gets an input, so if the parent of our component is going to change detection and is changing the input, then our component change detection will be triggered as well. So in our case, if this component, the parent, is transferring some input, if this component changed the parent and the input change, so this will trigger change detection on this as well. So this is the input. The third change detection is calling detect changes, or calling detect. The third one is when we're using a sync pipe. So in our example, usually in the OnPush change detection strategy, what you want to do is you usually transfer data to your template using observable or using ngrx stores or ngrx component or some library that sends the data as observable. And in the OnPush change detection strategy, you usually subscribe to their observable using the async pipe, because we know the async pipe works in the OnPush change detection strategy. So and the async pipe will subscribe to an observable. So we have here a low observable containing the a subject, not a behavior subject, containing the initial value world, and you subscribe to that subject using a sync pipe. And this is a good way to transfer data in the OnPush change detection, since it's when the hello, when the observable is changing, a sync pipe will cause the component to undergo change detection. So this is the third one. And the fourth one in the OnPush is using change detector ref, detect changes, or mark for check. So in the constructor, you can inject change detector ref, which the view ref has a change detector ref property, which triggers the change detection and calculates the change detection in the view ref. So you can inject the change detector ref of your component, and then you can use this change detector ref and call mark for check. Mark for check will trigger change detection will mark from the top component until it reaches the component that we're currently called mark for check. So mark for check, if you called mark for check in the bottom right component, then it will mark the top one, the next one, and this one as dirty. So mark for check actually marks dirty up the tree. And also you can call detect changes. Detect changes works down the tree up until it reaches a component that has a change detector, a strategy of OnPush. So what detect changes will do, it will trigger change detection. Mind you that detect changes works synchronously. So it will trigger, if we call detect changes on this component, the middle right one, it will trigger change detection in the middle one and then go down the tree. If this component is not in the OnPush change detection, it will trigger change detection in this as well. So this is a summary of the OnPush change detection strategy. So we have the default automatic change detection, the OnPush semi-automatic change detection, and we actually have a third change detection, which is manual zoneless change detection. And in this mode, we'll learn it in this lesson. In this mode, you can run the entire component tree, or you can run part of your component tree outside zone.js. And in this mode, you need to actually specify when to trigger change detection by manually calling change detector ref detect changes. That's what we call the manual change detection. You actually need to specify on which component and when to trigger change detection by calling change detector ref detect changes. So you can actually call it directly by using the dependency injector, injecting the change detector ref service and calling detect changes, or you can create some kind of directive or pipe or event plugin manager that will call it for you. So you can call it directly or indirectly. Another option to trigger change detection in a zoneless mode is calling the application ref, which you can actually also inject using the dependency injector, and calling the tick function. The application ref tick function will traverse your entire tree of components and will trigger change detection on your entire tree of components. So we have the default automatic, the OnPush semi-automatic, and the third one, we actually have a zoneless when you run your entire component tree outside Zone.js or part of your component tree outside Zone.js. In terms of performance, working in zoneless is the most performant change detection strategy you can choose. So if we're trying to compare the number of change detection on a component, and we're looking at the automatic default change detection, so we might have a component that trigger 1,000 times change detection. If we have the same app in an OnPush, and of course those are arbitrary numbers, if we have the same app in an OnPush change detection strategy, that same component will probably have less change detection cycles. So I said, like, let's say 100 change detection cycles. If we're working in a zoneless, this component is in zoneless mode, so it might be triggered 10 times change detection. So the total change detection cycles on each component will be fewer if you work in zoneless mode. So in general, and it is our recommendations to don't use the default change detection. So we recommend not to use the default automatic change detection. Maybe if you're creating a small site with not a lot of events or a lot of chain detection cycles that are triggered, maybe a simple landing page or something like that, it might be forgivable to use the default chain detection. But on most Angular apps that you create, do not use the default chain detection. Rather, at least choose the OnPush chain detection. And if you want even better performance, you're afraid you have a lot of chain detections that are triggered, your users entering a mobile through their mobile to the app, and you want good performance on mobile devices, in that case, you should consider going in the zoneless, Angular zoneless mode. In fact, we do not recommend the default chain detection, so we do recommend that in your Angular app, you go to the file called Angular.json. Angular.json is a file where you can configure Angular CLI, and you can configure your workspace. And in here, you can add, in Angular.json, you can add schematics, a schematic key with where you define schematic Angular component. And then you can say that it's basically saying that when you use Angular CLI to create a new component, you can mark that the change detection will be on push, and we'll have that segment of code in the article written, so you can copy that section of code. Now, when you add this to your Angular JSON, you can open the terminal, and then you can create a new component. Let's say npx ng generate component, and let's say check cd strategy. I'm creating a component, and when I'm creating now a component and you add this code to the onPush, if you examine your component, I'll go to the component that is generated, and you can examine that that component is automatically has a change detection on push. So you can actually configure Angular CLI to automatically create your component in an on push. So we highly recommend not to use the default change detection. Instead, either use the OnPush or zoneless. In addition, you don't have to make your entire Angular app zoneless. You can adopt zoneless incrementally by having a subtree of your components work in zoneless. We'll cover this later in this lesson. And then you can make that subtree a bit larger until it encapsulates your entire tree of component, and then you can transition your entire Angular app to zoneless. So the decision to go zoneless, it can be combined with the OnPush, and just some part of your tree make it zoneless, and make the zoneless tree incrementally adopt the zoneless by making that zoneless tree bigger until you can drop Zone.js entirely from your project. Time for us to write some code to really understand how Zoneless work. So what we're going to do is we're going to set up a new Angular project and make this project work in Zoneless. So we're going to use Angular CLI to start a new project. We are then going to go to the polyfields file and remove zone.js completely from our bundle. We are then going to go to the entry point file and tell Angular to bootstrap our root model, but do not use zone.js. So open your terminal, start a new Angular project using Angular CLI. So I'll write npx Angular CLI new, and we'll call it Zoneless tutorial. We're going to wait a few seconds for the project to be created. If you're using npx for Angular CLI, it will ask you if you want to install the following package. I'll answer yes. I'm going to let him create the project. He will probably ask me a few questions. We're not going to add routing. We're going to focus on Zoneless, not on routing. And we are going to not focus on CSS, so I'm going to choose CSS. I'm going to wait a few seconds for the project to be created. Great, our Zoneless project is created. Angular CLI finished creating our project. We can now cd into the created folder Zoneless tutorial, and we can open that folder with our IDE code dot, and this is our project. Now, if we want to make Angular go Zoneless, we need to do a few things. If we want to go completely Zoneless, remember that Zoneless does not mean you do not have to remove zone.js completely. Zoneless can be part of your subtree, not every time you want your entire app to be Zoneless. So but in this example, the entire app is Zoneless. So if you want to go completely Zoneless, so you need to go to the polyfields file, and in that file you will see in my code at line 48, import zone.js, comment this line, save the file, and then you need to go to the entry point file. And in the entry point file, we have the bootstrap of a root module, and the bootstrap model can get a second argument where you can define Angular options, and in here you have an option called ngzone, and you can specify the string noop. This means the Angular do not use zone.js. Now, to see the results, we can run our project by doing ngserve. And we can examine that we have a Zone.js app. We can do it a few ways. For example, we can go to the app component, and let's delete the app component HTML and CSS and the test file. Let's go to the app component, specify the template to be inline in the TS file and without styles. And we can examine that our app is working in Zoneless. For example, let's say we have a counter variable, and let's say we have a counter that is marked as 0, and then we have, let's say, a button to increment that counter. So let's create also a button, and we'll name it increment and subscribe to the click event of that button and activate increment method. So we'll add an increment method. And in here, we're going to go to the counter and add a 1 to our counter. And now we're running our app. So let's open the browser. Let's open our browser and examine our app. So I'm going to go to localhost 4200. We have a 0, and we're clicking increment, and nothing actually happened. This is because we're working in a Zoneless mode. In any other mode, in the automatic or default change detection, of course, our counter will be incremented. But in Zoneless mode, the counter is not incremented. If we actually want Angular to trigger change detection on our component, we actually need to go to the constructor and ask from the dependency injector to inject us with the change detector ref. And then in our component, in our method increment, we need to call we need to go to the change detector ref and call detect changes. And this will trigger the change detection, and we'll see our counter is incremented. So we know that we're on Zoneless mode because we actually need to call detect changes. Another way you can do is you can, for example, inject go to the constructor and inject the ng zone service. And in this service, basically Angular wraps the usage of zone.js through a service that's called ng-zone. So we can actually go to our method and we can, let's say, console log the zone service, the ng-zone service. And we can examine what we get here. So if I'm incrementing and looking at the console, we actually have a noop ng-zone. So we have a ng-zone service, which is the noop ng-zone service. So it's not the regular ng-zone in Angular zoneless mode. It is a ng-zone service that wraps pretty much nothing, a noop ng-zone. So we successfully managed to transition our Angular app and work outside of Zone.js. So basically what you need to do to make your Angular work without Zone.js, so to summarize this exercise, what you need to go to the file source polyfields and comment the Zone.js import. This is the first step that we did. And then to work zoneless, you need to tell AngularJS to not work. You need to tell Angular to not work in zoneless by going to the main.ts file and bootstrap our app without Zone.js. This is the part we did here in the main.ts ng-zone noop, and then also and this is what we did in the main.ts. So now we have our Angular app working zoneless, so we can actually examine how zoneless exactly works and what are the best practices to work and the best way to work in a zoneless mode. Now that we have our zoneless Angular app set up, let's do an exercise to understand how change detection is working on zoneless. And our goal in this exercise is to understand how do we trigger change detection, as well as understand on which components does the change detection is triggered on. So what we are going to build is we are going to create the following component tree. We are going to create we currently have a root component, app component. So we're going to create a child component, which the app component is going to place the child component, and we're going to create a grandchild component, which child component is going to place a grandchild component. And we're going to trigger and understand how we trigger change detection on child component and which components are affected. So we're going to trigger change detection on the child one component. So going back to our code, let's create those components. So I'm going to close the development server, and I'm going to generate a component, a child component. I'm going to add the inline template and inline style and skip test to keep the files to a minimum so we can focus on the actual experiment that we want to focus on. So I'm going to generate a child component, and I'm going to do the same command to generate a grandchild component. Okay, so I created the two components, and now our app component will position below the increment button. It will position the app child component. Great, and the app child component is going to position the app grandchild component. Great, so we have our tree of components, and we can activate our development server back on. So do an ng-serve, go back to your browser, and we should see a tree of components. We have our app, placing child and placing grandchild works, and we can actually open the developer tools, open the Angular DevTools extension, which you probably have installed. If not, please install it. And in the Angular DevTools extension, we see our tree of components. The app root is positioning the child component, and the child component is positioning the grandchild component. Great, now it's time to experiment with the change detection. Let's have child activate change detection and see which component is affected. Going back to our code, we will now go to the child component and trigger change detection. So in the child component, we are going to add a button, and we're going to name that button trigger change detection in child. And the button will have a click event, and in that click event, we'll activate a method called trigger change detection. And in this method, we are going to trigger change detection in the child. So let's create the method. We can delete the on init. It's not needed here, and the implements on init, and trigger change detection. So to trigger change detection, one of the ways you can do that is you can ask for the service change detector ref of your component. You can ask it from the dependency injection. And then you can go to the method we want to trigger change detection, and you can grab this service and call detect changes. This is one way you can trigger change detection in a zoneless Angular app, in zoneless mode. So don't get confused. Detect changes, you can also call mark for check in the when you're in an OnPush. Mark for check will work as well, but mark for check still uses zone.js, uses zone.js. So this will not trigger change detection in zoneless. Okay, so mark for check is not triggering change detection in zoneless. So just to emphasize, you have to call the change detector ref detect changes. So now that we called it, let's do something. It's not that elegant, but let's do a log for in our template. We know that when Angular triggers change detection, Angular calculates the dynamic values, those values that are binded in the template. So we can add a call to a log method. And in that call, we can print that we are now undergoing change detection. So we're going to print to the console that we have a change detection happening in the child component. And we're going to do the same log in all of our component trees. So we know that the child component is rendered, and we'll have a different log in the grandchild and a different log in the app component. So I'm going to grab this log method, and I'm going to go back to my grandchild component, and then we don't need the styles here, we don't need the on init, and then I'm going to print in the grandchild that we are now undergoing a change detection in the grandchild component. And I'm going to do the same, and I'm going in the template of the grandchild to call during change detection the log method. Now I'm going to do the same in the app component. So going back to our app component, I am going to create a log method, but this time it prints that change detection is happening in the app component. And we are also going in the template, and we're going to call this log method. So right now we have change detection happening in the child component and log messages in all the components that we know so we can tell that change detection is happening. So going back to our app, examining the console, we now have app components, change detection, child, grandchild, and then app component, child component, and grandchild called again. Why is it called again? Let's clean up some console log noise. Go to your main TS file, and we have here in line 7 to 9, we have if we're running in production, if we have an environment variable set to production, environment, not environment variable in the environments file, we have environment for production in TS, and in here we have production set to true when you run Angular and when you build your app in production. So going back to that if we are running in production, run Angular in production mode. Angular has two running modes, one development, run Angular in development mode, and run Angular in production mode. Now, when you usually when you develop, you want to run Angular in development mode. When you're running Angular in production, you want to run Angular in production mode, which is kind of obvious. But one of the things that Angular is doing in development mode, Angular is running change detection twice. Why is Angular doing this? Angular expects stability when it's doing change detection. It expects to run the change detection, get a result, then have stability, then run it again, get the same result. So this is why Angular runs change detection twice. And usually you want that in development, because then you get error like value changed before checked error or something of that line. And this is called because Angular ran once, got a result, and ran another time got a different result. But for our experiment, we are going to comment out that if and run Angular in production mode. And it's not recommended to do it in your Angular app. Okay, run in development mode when you're developing. It's a good default. But for us to clean the noise and just run Angular change detection once and not do that comparison, we're going to enable production mode. And now we see that our app component, child component, and grandchild component has change detection. And when we trigger change detection in child, we see that child component and grandchild component went through change detection. So we see two components of our components tree went to change detection. When we ran detect changes on child component, it triggered change detection on child 1 component, and it triggered change detection on the grandchild component. Okay, when you call detect changes, it goes when you go to a component and you call detect changes, it goes down the line from your component. It walks down the tree from that component down to the to every to the sun to down the tree from that component to the child, grandchild of that component. So what it does, you call detect changes, it goes down the tree. Another way you can trigger change detection is injecting a service called application ref. Application ref. Now, when you bootstrap an Angular application, Angular represents the application running with a application ref service. And using this service, instead of detect changes, you can grab this, this service and you can call tick. What tick will do, it goes from the top of your tree of components. So it goes from app component down the tree. So what happens here now is if you go and examine the trigger change detection, if you have application ref tick, it goes from the top of the tree, renders app component, child component, and grandchild component. Okay, so this is very interesting. It actually traverses down the entire tree, but does it traverse the entire tree all the time? And will detect changes also go down the tree all the time? Let's examine what happens if you work in Zoneless and turn all your components to OnPush. So going back to our code, I want to examine the effect of getting our components, changing our components to an OnPush change detection strategy. So I'm in the child component, and now I want to set the child component to change detection strategy OnPush. Now, when you're not working in the OnPush change detection strategy, basically, if this is not on, what it means that the child component view ref is marked as dirty automatically when the parent is going through change detection. So if child component parent is going through change detection and you're not in an OnPush, child component will also go to change detection. It will be marked as dirty if the parent is marked as dirty. But if you turn change detection OnPush, change detection strategy to OnPush, then the child component would not necessarily undergo change detection if the parent goes to change detection. So it's not automatically, it's on certain conditions. So when you're not in OnPush, your view ref is marked as dirty based on the parent. When you're in an OnPush, the view ref is marked as dirty if certain conditions happen. And let's examine what happens now when we call application ref tick, but let's change the change detection strategy to OnPush for all our components tree. So let's go to app component and add here as well change detection strategy OnPush, and also we'll do the same for the grandchild component. We'll go on and add a change detection strategy OnPush. Now we check what happens when we grab the application ref service and call the tick method. So let's go back to our browser and examine the result now. If I click the application ref tick method that is activated from this button, what happens is it prints that it goes change detection from the top of the tree, because this is what application ref is doing. It's starting from the top of the tree, and it's gonna reach down to the component that actually called the method, child component, but it will not necessarily go down. If it stumbles on a component like grandchild that is on the OnPush state, it won't drift down to that component as well. So it will stop until it reaches my component, continue down until it reaches a component which does not have OnPush change detection strategy. And if it stumbles down from my component to a component with an OnPush, it won't activate change detection on that component. So this is the result of the tick. Go down from the top of the tree, go down until my component, and then only continue if the rest down the tree are also in the OnPush. Now let's try the change detector ref detect changes. So let's check mark this, call detect changes, and see the result. And I'm gonna click trigger change detection in child to activate the detect changes, and I see it only activates in the child component. So basically, rather it's tick or detect changes, it's not gonna continue down the stream if it stumbles on a component with an OnPush. So this means that basically what we did with detect changes is with detect changes and the OnPush, we improved the performance even further, because we minimize the amount of components that undergo change detection. And Actually, if you have your entire tree of components in an OnPush and working in Zoneless, this is probably the best in terms of performance change detection that you can have, where you're going to trigger the minimum amount of component change detection. And actually, you're going to only trigger one component that calls detect changes. If everyone is an on change and you're calling detect changes, it will only trigger one component, the component that should change. So this is, in terms of performance, the best in terms of performance to turn your entire Angular app to zoneless and switching the entire component tree to OnPush. So summarizing how change detection works in an Angular zoneless app. So one way to trigger change detection is to call change detector ref detect changes. And in this case, if you're calling detect changes, it's going down the children until it stumbles. It's going from the component that called detect changes and going down to the children until it reaches a component that called an OnPush. That is in the OnPush change detection strategy. And if your entire tree of components is in the OnPush, calling detect changes will only trigger change detection in a single component, the component that called detect changes. Another way to trigger change detection is calling application ref. Application ref tick. In this case, application ref tick goes from the top of the tree until it reaches the component that called the tick method, and it will go down further only if the further down does not have an OnPush change detection. So it basically continues down until it reaches until it finds an OnPush component. And if your entire tree of component is an OnPush, so it will start from the root component and it's going to reach your the component that called the tick method. Now, just to show in a diagram, if we have zoneless without OnPush, so we don't change OnPush to any of our components tree. So if you call detect changes on child 1, your entire subtree of child 1 will undergo change detection. This is the case when you don't have OnPush. You're calling detect changes on child 1, and all the components under child 1, including the further down the tree, all the components down will undergo change detection. And probably the most performant change detection strategy is going zoneless, where all your components in an OnPush all your components are on the OnPush change detection strategy. And in that case, if you have child 1 component call detect changes, only child 1 component will be rendered. So this is the most optimized performance in terms of change detection. A benefit we have in working in completely zoneless, if you remove zone.js from Angular, it will reduce your bundle size. So in this exercise, what we're going to do, we're going to check how much bundle size reduction we get if we remove zone.js. And it's pretty simple to check, right? So we're going to build our app with zone.js and check the amount of the size of the files. And we're going to build our Angular without zone.js and then check the size and then do a comparison between the two to understand exactly how much bundle size is saved when you remove zone.js from Angular. So let's go back to our code. And in our code, we are now working in zoneless. So we can start by building our app, run it npx ng build to build your app. And we're going to wait a few seconds for our app to build. Okay, so this is the build we're getting. The file sizes, we have the main, the runtime, and polyfill. We have the raw size, the actual size of the file, and we got an estimated transfer size. The file size will usually, when you transfer JavaScript static files, you usually use compression like gzip. So it's not like you're serving the exact file. It's usually going to be compressed. So this is the right side. After compression, it will probably be this size. So you get the actual size and the compressed size. Now we can check the file sizes and compare it with an Angular app that runs with Zone.js. So let's include Zone.js. So to include Zone.js, we're going to polyfills and we're going to uncomment Zone.js and we're going to main ts and comment out the ng zone noop and then build our app again. And this time, when we build, it's an Angular version with Zone.js. And what we'll do a comparison between those files and see the result. So now we build our app again, and this time we got different results in our file sizes. Specifically, the most significant one is the polyfills. So the polyfills has a raw size of 33 0.09 in with Zone.js, and if we go up without Zone.js, the polyfills is pretty much very minimum, very minimal. So basically, you save the polyfill 33.09 kilobytes and approximately 10.63 when it's compressed. So Zone.js doesn't make your bundle size really big. You see that it's not as big as I imagined the first time I removed it. So there's not a lot of reduction in bundle size, but it's highly dependent on what you're doing with your app. So if you're expecting users from the mobile and without fast internet connection, this could be significant. But my guess is most apps, it's not that significant, the reduction in bundle size. Okay, so we now know how to trigger change detection in Zoneless, as well as which components undergo change detection when you trigger it. And we also know the benefits of using Zoneless and combining it with an OnPush. I would still keep the OnPush while I'm going Zoneless, and this will minimize even further the amount of components that undergo change detection and will optimize your performance of your app even further. Now I wanna discuss about a major caveat that we have in Zoneless, and that is library support. So what I'm going to do in this exercise, I'm going to try to combine in my Zoneless app, I'm going to try to combine Angular Material and check out if Angular Material, which you know that it's one of the popular libraries in Angular, and if this popular library doesn't work, it probably reflects on a lot of library with less contributors and with less maintenance. And it is important for us, the library support. One of the benefits we have in Angular is a big community infrastructure with a lot of libraries. So I want to check what happens to Angular Material in a Zoneless app. So I'm going to go back to my code, and I'm going to close the developer server, and I'm going to do npx ng add, and I'm going to add Angular Material to my project. npx ng add Angular Material. We'll wait a few seconds, probably ask us a few questions. We will install the latest Angular Material 14. Yes, we want to proceed. Installing packages. Probably ask us about the theme. It doesn't matter, we're not going to focus, just choose the first one. And it doesn't matter the typography as well. Let's say no. Let's enable animation. Probably most of you are using Angular Material with animation, so let's enable that. And let's wait a few seconds for the package to be installed. We see that it installed the package, it updated our app module, and our app module now contains the animation module. And we now can use Angular Material. So what I want to do is I want to add a material checkbox, right? So I'm going to import from Angular Material. I'm going to import Angular Material from Angular Material checkbox, the module, mat checkbox module, and add it to the imports array. Great. We can now use the mat checkbox component. So I'm going to go to the grandchild component, and I'm going to place here the mat checkbox. So under grand works, I'm going to do a mat checkbox, and let's write check if material is working. Okay, so let's check out our app. Let's do an ng serve again, and let's examine if our checkbox is working. So I'm going to open the browser. Okay, so we see our checkbox here. Now, I don't remember if we're working in Zoneless. I think when we built the bundle, we added a ng zone nope. So let's restore so we work in Zoneless. Okay, and let's examine now the checkbox. Now that we're working in Zoneless, I want to see if we have good library support. So does Material work in an Angular Zoneless app? So I see that I click the checkbox and nothing happens. Nothing happens. So Material doesn't work in a Zoneless. In fact, if you write Angular Material Zoneless, you're going to find an issue in the Angular Material repository where they specify that the Angular Material components do not work in Zoneless. So there is an open issue for this. So And why is this issue actually happening? This issue is happening if we check the Angular material code, the code of the checkbox, we see that we have a mat checkbox component that we're using. Angular material, as well as other component libraries with big community support, are probably working in change detection on push. So as well as Angular material, the components in Angular material are in the OnPush strategy. So in the OnPush, remember that events in OnPush trigger change detection, right? In OnPush, when you have an event, it triggers change detection from the root component and down to your component, and might continue down if the rest of the components are not on push. So it will continue down until it stumbles in the OnPush component. But basically, event in OnPush from top to your component and maybe down further. So the material components are in the OnPush. Now, if we check the checkbox template, we see that the checkbox relies on events. So Angular material components rely on events and expect that during those events, your app will undergo change detection. But events do not trigger change detection in a zoneless app, right? Remember, detect changes. Change detector ref detect changes triggers change detection, as well as application ref tick, but not events. So this is why Angular material will not work in an Angular zoneless app. So that's a big deal, right? We'll lose every library support if we go zoneless. Wait, there is a solution, a really simple solution for you, which we're going to show you next. Solving our problem is really simple, and it's not only going to solve Angular material problem, but it also will give us support for any third library that Angular has. So it solves our problem perfectly. And this is a library we wrote at academeez called academeez zoneless, AZ zoneless. And to install this package, we'll do npm install AZ zoneless. We'll go back to our project, close the development server, place the installation command. Now, when you install the package, it gives us a module we need to add to our root module. So go to app module, and we're going to import from AZ zoneless the module here, which is called zoneless module, and we're going to place it in the imports array. And that's about it. This is all we need to solve our third library support for components that need the events for their change detection. So we install the zoneless. Let's verify that our app works. We'll do ng-serve again, and we'll examine the checkbox again. So let's go back to our browser. Okay, our app is running. We have the checkbox, and now the checkbox is working. Great. Now, how did this library solve our problem? What this library is actually doing, let's examine the code. In project AZ zoneless, we have in the lib a few event managers. And one of the event managers is zoneless, I think, event plugin. Let me see. Yeah, so this is the one. What this library does, it subscribes for an event manager plugin. So Angular allows you to add event manager plugins, that is services that subscribe to certain events. It allows you also to create your own custom events. So basically, you need to add a method called supports, which return true or false if you're supporting this event. So if we are in zoneless, if we are in zoneful where this event manager plugin will not work, it's only working in zoneless. And what it does, it's going to detect an event that happens like the checkbox events, and it's going to run this, and it's going to do application tick at the end of the event. So it's really simple. It's an event manager plugin that subscribes to the old Angular events, but runs application ref tick at the end of those events. This means that now, when usually we said that events do not trigger change detection in zoneless. Now the old events do trigger change detection from the top component down to the component where we had the event. So similar to OnPush, when you have an event to OnPush, it will work the same. So basically now we have a support for events. Events will trigger change detection. So our work with zoneless is going to be very similar to the OnPush strategy. In fact, we're going to everything is pretty much going to be very similar. So you're going to need to manage the data with observable. We're going to use something similar to the async pipe, but now the old events are working as well, and you have your third library support. Let's examine this library. Academeez Zoneless has a few more cool features other than the support for third-party libraries. Other than support for those libraries, it has also a few other cool features which we'll go over them now. Probably the most important feature of the Zoneless library is the fact that it has a set of directives which allows you to incrementally adopt Zoneless. So, and this is probably the most important thing you will take from this video. You don't have to completely remove Zone.js. If you have a big app, completely removing Zone.js is not as simple as it seems in this lesson. It has a lot of complexities. So the better approach would probably be look at your tree of components and start by a subtree of your components and making a subtree of your component work zoneless. And you keep the zone.js, you do not remove zone.js, but you take part of your component tree and you make that part zoneless. And you gradually make that part bigger and bigger. Or for example, you have a part in your component tree which has a lot of change detection, a lot of poor performance, a lot of users going through mobile and have bad mobile experience in that component tree. Then you can decide to take that particular component tree and make that particular component tree zoneless. So consider this: if the step to remove zone.js is too big for you, you can incrementally go zoneless. So you can take part of your subtree and make it zoneless. So you have a set of directives in the Academeez Zoneless library, AZ zone full and AZ zone less. Let's start with AZ zone less. AZ zone less is a directive that wraps part of your tree, and that part of the tree will work outside of Angular zone. And AZ zone full will restore if you're in a AZ zoneless. If you're outside Angular zone, it will take a part of your component tree and restore that part back to the Angular zone. So these two directives are working with Zone.js in an Angular app with Zone.js. So in an Angular app with Zone.js, you can take the AZ zoneless and decide that part of your tree will be zoneless. And as we said, it allows you to incrementally choose part of your subtree to be outside of Zone.js. So let's do this example. We have in our app, we have app component, child component, and grandchild component. I want to take the child component and grandchild component, and I want to run them outside Zone.js. So now I want an Angular app running with Zone.js and just make part of my subtree work zoneless, just to demonstrate how you can incrementally adopt Zone.js. So let's go back to our code and let's make our app zoneless again. Let's make our app zone full again by going to the polyfill, restoring the import zone.js, and going to the main TS and removing the ngZone noop. At this point, my Angular app is working with Zone.js again. Great. Now I want my part of my component tree. Let's go to the app component. The app component is placing the app child. Now what I can do, I can place, for example, a div. I can create the directive AZ zoneless, use this directive AZ zoneless, and place the app child inside that div. Everything inside this div, including the div itself, it will be running outside Zone.js. So this includes the app child will run outside Zone.js, and also app child places app grandchild, which also runs outside Zone.js. So we place the child1 component and grandchild component outside Zone.js without removing Zone.js. The rest of our app is still working with Zone.js. And I can verify that it's the case. For example, the child has a button which activates trigger CD. Trigger CD, let's do this. We can console log zone.current.name. So if you haven't checked out our Zone.js lesson, this essentially prints the current zone that you're in. So if you're in an Angular zone, it will print Angular. Okay, Angular create a zone context called Angular, and if you're outside, it will be something like root. So let's see. Let's click the trigger change detection in the child just to see that it works. So trigger change detection in the child, we see that it prints root. So this means that the child is currently running in zone current name in the zone root, so outside of Angular. And the same can be applied in the grand component. The grand component has also a button which prints do something. We can also print the console log zone.current.name to see which zone is the grandchild, and we're going to click the grandchild and we see do something and the root is printed. So we now know that we accomplished what we need, and we incrementally adopted Zoneless by taking part of our subtree and placing it in an AZ Zoneless directive to remove that part outside of zone.js. So think about that you don't have to completely remove zone.js. If you have a big app and you want to improve part of its componentry performance, just wrap it in AZ Zoneless and it will work outside of zone.js. So we covered some of the features of the academeez Zoneless library, which contains a set of directives and utils to help you manage an Angular Zoneless application. We saw that by just installing the academeez Zoneless library, we now have support for third-party libraries like Angular Material. Angular Material doesn't work in Zoneless, so you can install the AZ Zoneless library and import the module, and then Angular Material will start working in an Angular Zoneless app. We saw that using this library, we can incrementally adopt an Angular Zoneless application. We don't have to go completely Zoneless. We can take part of our subtree and make that subtree run outside zone.js by using the AZ Zoneless directive. We also have special events that prefix with AZ. Those events have a better performance. They only cause change detection on the component by calling detect changes. So now we don't have the event causing change detection from top to the component. It can cause only our component to trigger change detection and not from top to bottom. So we have those performance event, and we also have, we didn't cover those, but we also have a zoneless event. In case you do work with zone.js and you want to run an event outside zone.js, so we have a special events that are prefixed with AZ event name like azclick.zoneless, and those events will run outside zone.js. This is in case you have a zone.js library and you want to run an event outside of Angular zone.js. So this is the academeez Zoneless library we created. Feel free to start a library, write issues, and in general tell us what you think, and tell us if you managed to incrementally adopt, make part of your subtree zoneless, and did it improve the performance? So write your opinion in the comments below. When you're working with the OnPush change detection strategy, you probably use the async pipe a lot. Usually when we use the OnPush change detection strategy, we use observables and subjects and behavior subjects, and we transfer them to the template using the async pipe. And we can do that because the async pipe is something that causes change detection in the OnPush change detection strategy. Now the same rule applies also to Angular working in zoneless. So in zoneless mode, you will also transfer data to the template using observables or subject or behavior subject or promises, and connect them with a pipe. So let's try to use the async pipe in an Angular zoneless app. So let's open our app again, and in our app, we transferred our app to be zone full again. Let's make our app zoneless again by going to the polyfills, commenting out import zone.js, and going to the main TS and commenting back the ngzone noop. Now our Angular app is zoneless again. Now I want to try to use the async pipe. Since we are going to use observables and something like the async pipe to transfer data to the template, we will use observables to transfer data to the templates. I need to make sure the async pipe is working in zoneless. So let's go to our grandchild component and let's do this. Okay, now that I made my app zoneless, I have a problem with the zone current name that we placed, since zone will only be available if you import zone.js into polyfills. So let's comment out this line. And I think I'll also have in the child component a zone current name. Let's comment this as well. Otherwise, our app won't work. Let's go back to the grandchild component. And now below the performance click button, let's add a counter. So let's do this. Let's do our grandchild implements on init. and it will implement the ng on init, and inside this we'll do a timer that increments an observable. Or better yet, we can just simply do something like this. We can import from ngrxJS, we can import an interval operator that creates an observable that emits a counter every period of time. So we don't actually need to implement on init and setting an interval. We can simply do create a public counter which equals to interval that runs every second, every 1000 milliseconds. Now we have this creates an observable which emits 0 after a second 1, after a second 2, after a second 3. Now we can print to transfer that observable to the template. So usually in the change detection on push strategy, we would simply transfer the counter by going to the template and doing that our counter is printed using the async pipe, and there is no problem doing that in the OnPush since async pipe triggers change detection. So now if we activate our app and we go back to the browser, we see that our grandchild doesn't count. There is no counter here. If we click performance click and the performance click is doing AZ click, those events trigger change detection. If we click this, we see that change detection happens, and then it prints the counter. So the async pipe doesn't really work here. So the reason why the async pipe is not working is we can examine the Angular code, and we can go to Angular code. The async pipe is located in the common package, and in here we have the source, we have the pipes, and we have the async pipe. The reason that it's not working is that async pipe actually in the end what it does, it will use mark for check. Now mark for check, as we mentioned before, doesn't work in Angular Zoneless because mark for check still uses zone.js. It marks the views as dirty, and when zone.js triggers the next, tells to trigger the next cycle of change detection, then either in this cycle or the next, it will cause change detection to the view. So it's doesn't really work, the async pipe in a zoneless app, because the async pipe uses mark for check, and this is not supported in a zoneless app. So when you work in zoneless, you cannot use the async pipe. So what can we use? Do we have other solution? Because we still want to manage our data similar to the OnPush strategy in zoneless. So let's see the solution, what other pipe we can use other than the async pipe to manage our transfer of observables to the template. So instead of using the async pipe, we can go to ngrx, the same team that created the ngrx store, the most popular Redux implementation for Angular. They have a few more packages, and one of the packages they have you can view in their docs, and the view is called ngrx component. Now the ngrx component is a library for building reactive Angular templates. It provides a set of declarables that can work with or without zone.js. They give more control over rendering and provide further reactivity for Angular applications. So inside this package, we have a pipe called the push pipe. Now the push pipe, what it does, the ngrxPush pipe serves as a drop-in replacement for the async pipe. It contains intelligent handling of change detection to enable us running in zone full as well as zoneless mode without any change to the code. So this is actually better than the async pipe. For one reason, it works exactly like the async pipe in case you do run in a zone.js Angular app. So if you are in zone.js, it will work similar to the async pipe. So we have their implementation. Well, we're not going to go over the entire implementation, but something nice that they did in this pipe, if you have zone.js, then that you're using mark for check. Same as the async pipe is using mark for check. If you're not in a zone.js, then you're doing a mark dirty. Mark dirty is kind of similar to mark for check, but it actually do trigger a cycle of change detection. Mark for check does not trigger a cycle of change detection. It just marks views as dirty and to be change detected in this change detection cycle or the next one, or but it does not trigger change detection. While mark dirty actually does trigger change detection in a similar manner. This means that if we use this pipe, it will trigger change detection from the top component down to our component. So this is actually works like a sync pipe, or if we're zoneless, it gives us support for Angular zoneless app. So let's try to install this package. So the NGRX team has an easy ng add command for their packages. So we can go back to our code, close the development server, do a ng add ngrx component. This will add the ngrx component library. Ask, would we like to proceed? Yes. It's going to install the package, and it's simply installed the package. It did not update any module. It did not update any module because it's not something that you usually necessarily put in the root module. You sometimes use it either in a feature module, or you use it inside a component, the component providers. So we go back, let's go back to the app module and let's install it ourselves. So in the imports array, we're going to import from the ngrx component, we are going to import the push module. Now we're going to add this to the imports array, and after this you can use the ngrxPush pipe is defined in this module. So now we can go back to our grand component, and instead of the async pipe we can use the ngrxPush pipe. Now let's see our app in action again. So I'll do an ngserve, and let's see if our counter actually is now working and counts. So let's go back to our browser. Okay, so now we see that our app, we see that our app counts. So instead of, so you are still want to transfer data to the template using observables. You still want to do that. This rule is similar. Basically, you're managing your zoneless app pretty much similar to how you manage the OnPush change detection strategy app, where all your components are in the OnPush state, which hopefully you are already doing. So you manage the same way in a zoneless, so it's not a lot harder to go zoneless in an Angular app because you have the similar rules you have in the OnPush. You still transfer your data with observables, but now you cannot use the async pipe. Async pipe does not work in zoneless. Rather, you need to install the ngrx component package and use the ngrxPush pipe instead of the async pipe. Similar to OnPush, you use observable to transfer data to the template. That is why I recommend, whether you are using zoneless Angular app or you're working with OnPush, there are some libraries that will be easier for you to work with. So I highly recommend on using some kind of library, a state management library that transfer your data as observables. This way, that data can be easily transferred to the template, and use the async pipe if you're on OnPush, or ngrxPush pipe if you're in zoneless. So I highly recommend working with a state management library that transfer the data as observables. So you have ngrx store, which you have a chapter about ngrx library. So make sure to check that out, the most popular Redux implementation for Angular. It transfers the data as observable. So it makes it easy to work in OnPush or in zoneless. So I highly recommend this library if you're working in zoneless or OnPush. Also, ngrx has a library called component store. Also transfer the data as observable, but this time is a set of data for a component or a subset of your component tree. So ngrx store, you can consider it more global for your entire application state management. Well, component store, it's something more locally for a component or a subset of your component tree. But both of those libraries transfer the data as observables, which make it easy to work in the OnPush or in the zoneless app. So I highly recommend working with some kind of library that transfer the data as observable. This way you can easily subscribe to it in the template using the pipes we examine in this lesson. Also, just to close up this lesson, let's go over to summarize what are the benefits of going zoneless. What is the benefits of using a manual change detection and transferring your Angular application to be zoneless? The first thing that we examined in this lesson, we saw that if we remove zone.js, obviously our bundle size will be smaller. So I think it was approximately 32 33 kilobytes that we saved, that we removed from our bundle. Removing Zone.js means faster bootstrap. So Angular waits for Zone.js to monkey patch, timeout, and promises, so it will be aware of the context. So it's going to take longer to bootstrap your app if you're working with Zone.js. So obviously we have the benefits of change detection. As we mentioned, if you go zoneless, you have change detection on fewer components, and also regardless of fewer components, the amount of change detection that they will have is smaller. So the amount of change detection you have on smaller and on fewer components. So you can consider this the manual change detection. Going zoneless has the least amount of change detection and the fewer amounts of components, while going OnPush is a bit more, and going the default mode is trigger change detection a lot and on your entire component tree. So synchronous change detection, when you call detect changes, okay, so it's not on your application tick, but when you call change detection detect changes, it performs change detection synchronously. So a lot of your change detection will be performed right away, meaning faster, meaning you don't need to wait for Zone.js to shout out to Angular that it needs to perform change detection, meaning easier testing as well. So with synchronous change detection, and in general, you will have a faster app. So these are the benefits of of removing Zone.js from Angular and working in Zoneless. Of course, there are shortcomings to working with Zoneless. The async pipe won't work, so you need the ngrxPush pipe. You might need more calls for change detector ref detect changes, although we did notice that if we install the academeez Zoneless library, you have events that you don't need to call change detection, don't need to call detect changes, and you have performance event also. So you might need more calls to detect changes, but I think it will be probably similar to the OnPush, since we will manage our data like the OnPush with the observables and subscribing to them using the ngrxPush pipe. So you probably have a bit more calls to detect changes. Mark for check, as we mentioned, does not work. It works on OnPush. Obviously, it works in the default, but it doesn't work in Zoneless, since mark for check doesn't trigger a cycle of change detection. So you're going to need to replace that. Like the OnPush, you will need to transfer your data to the template with observables, but probably if you reach this advanced lesson, most of you are aware of the OnPush, and already you have all your components in the OnPush state, so it's not a big deal. You're already doing it in the OnPush. So similar to the OnPush, you will need to transfer the data to the template using observable and using the ngrxPush pipe. So just to summarize this lesson, Angular actually has 3 change detection strategy. The default and the OnPush, which you were already knew about, and now you discovered a new one called Zoneless. By the way, every one of those change detection, you don't need to transfer all your app for that change detection. Like OnPush, you don't need to make your entire component tree OnPush. You can have a subset of your components in the OnPush. Same thing applies to Zoneless. You can have part of your tree as Zoneless. We saw the academeez Zoneless library. You can incrementally adopt by using the directive az Zoneless. You can make part of your subtree go Zoneless. Sorry, the second bullet is a mistake. If you do decide to go zoneless, remember that you need to use the ngrxPush pipe instead of the async pipe. So in the zoneless, we are still transferring observables to the template. We are still managing our data using observable transfer to the template, but this time we need to use the ngrxPush pipe. I highly recommend using a state management library that transfer the data as observables, like ngrxStore. And you can incrementally, remember that you can incrementally go zoneless. You don't have to transfer your entire app to be zoneless. You can still keep Zone.js and have part of your tree run outside Zone.js. That's it. This is our lesson about the third manual change detection, going zoneless in Angular. Please, if you adopt zoneless, if you make part of your subtree zoneless, and you saw an improvement in the performance, or let us know what you think. Let us know what you think about the academeez Zoneless library. Star us. As usual, we have the source code. We have a link to the source code below. That's it. Thank you for listening.